All right, welcome to Crack It. My name is Martin, and in this video, I'm going to talk about a really nice command which is available under the iOS XR operating system. Although it is not a really well-known command, you will see the power of it. Let me let's start. Okay, we're talking about the iOS XR pattern config replace. It was introduced many years ago. And although it is not really well known, it has a lot of power. The feature basically allows the user to replace configuration based on an interface identifier or a string pattern. The use case, for example, is that imagine that you are about to migrate a gig interface to a 10 gig interface, and you have a lot of configuration related to that gig interface. This command will allow you to easily manipulate the router configuration and move around configuration blocks. For example, if we take a look at the image here, we can see that we have our source interface, which is interface X, as in our example is our gig interface, and we have our target or destination interface, which is interface Y. All the related configuration to interface X will be replaced with interface Y. This is what this command will do. How to do so? Okay, we gotta go to the global configuration mode and type replace. We can see that it offers two options. One is for interface replace and the other one is for pattern replace. The command functions just like any other configuration command. I mean, it requires the commit to have the change applied. And guess what? There is some good news. It also offers a dry run option, which was added as an easy to use extra cautionary measure because regular expressions in parent string are very powerful, but at the same time, if they are not used properly, they can lead us to unexpected results. Okay. In other words, if you want to be really cautious and want to make sure 100% that the target configuration is the expected one, you gotta use the dry run option prior to committing the changes. Okay, we have the interface-based replace operation where you specify the source and the destination interfaces respectively. This is a this is an example where you type replace interface, the source interface, then the keyword with, and finally you type the target interface or the destination interface. Just for your knowledge, replacing interface X with Y will also cause all sub-interfaces hosted under X, for example, x.abc, to also be replaced with Y. For example, if you type replace interface gig 0001 with gig 0002, it will cause subinterface gig 0001.100 to be replaced to gig 0002.100. Take this into consideration prior to using this command. All right, less blah, 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 and more configuration. Let's run some examples of what we have done so far. In this case, we will be using an ASR 9901, and this ASR is running the version 772. Okay, let's see. The first thing that we will replace with our powerful command is the configuration related to gig 0007. Okay, let's see. It has a description and also it has an IPv4 address, but it also is listed under the OSPF 10th process. You see that it is listed under area 200 and it also has a transmit delay option applied. We're going to replace this gig 007 with interface loopback 99. For that, we gotta go to the conf mode and we are going to apply the following command. Let me show you. Okay, we type replace. In this case, we're going to replace an interface and its ID is gig 0007. Then we have to add the width keyword, and right after that, we add the target interface, which in this case is loopback 99. Where we're going to use the dry run option just to make sure what will be replaced or how the target configuration will look like. In this case, we're going to remove gig 0007 and configure loopback 99 with the description that this gig had. We also use the same IP 10, 20, 30, 40, which is the same as in this case. And we are going to remove gig 007 from OSPF 10 at interface loopback 99. And under interface loopback 99, we are going to add the transmit delay 5 option. Okay, now that we have ensured that this is the expected configuration, we're going to remove the dry run option. We're going to apply the replace command. We're going to see the configuration and finally let's commit. Okay, if we type show run interface gig 0007, we're going to use that it doesn't exist. It is no longer in the configuration, but instead we have interface loopback 99. Show run interface loopback 99 with its description and its IP. And it's also listed or applied under the OSPF process. Show run router OSPF 10. There you go. Okay, it's listed and it also has the transmit delay option. Okay, let's move on to the next example. We are going to replace the pattern of 10, 20, 30, and 40, and we are going to replace it with 100, 200, 250, and 225. Okay, how to do so? Let's go to the conf mode and let's apply the following command. Let me show you really quick. Okay, we use the replace command. And in this case, instead of using interface, we're going to use a pattern. Which pattern? This one, 10.20.30.40. With what? With 100, 200, 250, 225. And let's do a dry run of this configuration. Okay, this pattern matches with this statement of the access list, my list, and it will replace with 100, 200, 250, 225. And we also see that the IP of loopback 99 also matches the pattern and it will also be replaced. The description of gig 0001 also matches and will be replaced. And finally, we have a route policy, which is its statement matches the pattern and it will also be replaced. Okay, let's commit the configuration. Prior to doing that, let's apply the command without dry run option just to parse the configuration, and then we apply the commit command. If we take a look at the configuration of this portions of the config, we can verify what we have done. Okay, show access list, IPv4, and the name, my list. Let's see the content. Okay, the first statement, which is number 10, was already replaced with the one that we were expecting. If we take a look at the configuration of, or the IP of the loopback 99, we can see that the IP address was already replaced. If we take a look at the description of gig number 0001, we can see that the description was already replaced. And finally, we can do show RPL, route policy, and the name of the route policy is temp. We will see that the content is what we were expecting. The pattern was already replaced. All right, final example. In this case, we're going to replace a bunch of interfaces. We're going to replace gig 0001, which is here, show run interface gig 0001, 0002, and 0003 with interface 10 gig 00011, 10 gig 00012, and 10 gig 00013. How to do so? Let's go to conf. Let's apply the following command, and let's take a look at it. Okay, we are going to use replace and the pattern option. Which pattern? Gig 0000 from 1 to 3 with what? With 10 gig 000 11, 12, and 13. This is what this command does. Let's do try run. We're going to see that we're going to replace this with this, this with this, and this with this. Okay, let's remove the try run option. Let's replace pattern. Let's take a look at the final configuration. Okay, and then we can commit. Let's see, let's verify what we have done. Okay, show run interface 10 gig 00011 with its configuration, 12 with its configuration, and finally 13 with its configuration. All right, this is the power of this command. Although it is not really well known, it has a lot of power. I hope you enjoyed this video. Thank you so much for watching and stick around. Bye bye.